Hello. So welcome to Elements of Civil Engineering and Mechanics class. Today we are going to discuss about moment of a force. Moment of a force. So let me consider a force F, so acting like this. So I need to take moment of this force, say about this point, say O. So to get the moment of this force about this point, what I do is I am going to draw a perpendicular line to the line of action of the force from the point O. So let the distance be d. Okay. And this distance is called the lever arm. Okay. So moment of this force about this point is going to be the force multiplied by the perpendicular distance. And this force is causing a clockwise movement about the point O. So imagine you are having a thread of length d, that is this length. We are trying to take the moment of this force about this point. So keep one end of the thread at point O fixed and move the other end in the direction of the arrow. So this force causes clockwise movement about this O. Is it clear to you? Similarly, if I take another point here, say O dash, let d dash be the perpendicular distance from the point O dash to the line of action of the force. Then what is the moment of this force about this point? The moment of this force about this point is given by F multiplied by d dash. Okay. And what kind of moment is that? So again, if you move in this direction about point O dash, so that force causes counterclockwise moment. So the moment is negative. So that is, we are going to follow certain sign convention. We are in that sign convention, what we do is any moment which is in the clockwise direction as positive and the moment in the anti-clockwise direction as negative. Okay. So a given force causes clockwise moment or anti-clockwise moment depending on about which point you are taking the moment of that force from. Is it clear to you? So moment of force about O, I am going to call that as MO. So F multiplied by D. Okay. So what kind of moment is that? That is clockwise moment. Similarly, moment of the force F about O dash, I am going to call that as MO dash, that is equal to F multiplied by D dash, and this is causing anti-clockwise moment. Look, the same force, so that force causes clockwise moment of magnitude F multiplied by D about the point O. Same thing about the point O dash, it is causing anti-clockwise moment. Okay, I repeat, whether that force causes clockwise moment or anti-clockwise moment of any magnitude depends on about which point you are taking the moment from. Is it clear to you? So this is all about the moment of a force. Let us go with couple So let us consider two forces. So two forces of the same magnitude which are parallel and acting in the opposite direction and separated by a definite distance d. These two forces form a couple of magnitude f multiplied by d. So what kind of couple is this? This is a clockwise couple. So is it clear to you? So couple two equal and opposite forces, equal and opposite parallel forces separated by a definite distance for a couple. From figure, moment of the couple equal to f multiplied by d, and the couple is a clockwise couple. Okay. Coming to next, if I take the magnitude of the couple about any point, here I can take a point here, 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 or I can take anywhere, even just 1 kilometer away in the same plane, then the magnitude of the couple and the nature of the couple remains the same. So to prove that, so I am going to consider this couple. So I am going to call this as A. There is a point here. I am going to call that point as B, point C. So I am going to call this as point D. Okay. So this distance, of course, is D. Moment of the forces. What are the forces? We have two forces, that is F and F, about the point A, about the point A, I am going to call that as MA, is given by, see, if I take this force, so moment of this force about this point is 0. Is it clear? Because if there is a point O, if there is a force F, so if this is the distance D, so moment is F multiplied by D. What if I reduce this distance? So as I reduce this distance, the magnitude of the moment reduces. Okay. So once I move this force exactly on the line O, exactly on the point O, so D becomes 0, then the moment becomes 0. Say here I am trying to take the moment of these two forces about this point. So that causes 0 moment, that is this force F causes 0 moment about the point A. So that is F multiplied by 0 is the perpendicular distance, and if I take this force about this point, this is causing a clockwise moment of magnitude F multiplied by D. F multiplied by D plus, because according to our sign convention, any clockwise moment or couple is considered as positive. So that is equal to F multiplied by D. Okay. Next, I am going to take the moments of these two forces about point B and I am going to add them algebraically. Therefore, moment of the forces about the point B, so I am going to call this as MB. So now there is a definite distance, that is AB is the perpendicular distance to the line of action of the force from the point B. Therefore, F multiplied by AB is the moment this force causes about the point B. So what kind of moment is this? This is a clockwise moment. So according to our sign convention, it is positive plus. Next, there is one more force, that is F multiplied by BC. That is F multiplied by BC. What kind of moment this force causes? Again clockwise plus. So that is equal to F AB plus BC. F. So what is AB plus BC? That is AC. What is AC? That is D. So FD, again it is a clockwise couple. Okay. Next, moment of the forces about the point C, I am going to call that as MC, that is equal to F multiplied by AC, that is D, F multiplied by D, and that is causing clockwise moment. There is one more force F, and this F is passing through the point C. So this force does not cause any moment about the point C. Therefore, F multiplied by 0. It does not matter whether this is plus or minus. So that is equal to FD, again clockwise couple. Let me take the moment of all the forces about the point D and add them algebraically. That is moment of the forces about the point D is MD, that is equal to, so let me take this force. So that is this force multiplied by this perpendicular distance, that is F multiplied by AD. F multiplied by AD. What is the sign? This force is causing a clockwise moment about the point D. So I am taking this as plus. Next, there is this force F. So and this force is causing an anti-clockwise moment about the point D. So it is F multiplied by CD. Okay. So because this is anti-clockwise, according to our sign convention, this is minus. So I am going to take minus out AD minus CD. AD minus CD. So AD minus CD, that is equal to AC, AC equal to D. So that is F into D. Okay, here this is greater, this value is greater than this. So this has plus sign, so this should be having the same plus sign. That means it is a clockwise couple. Okay, so look at the magnitude of the couple, FD. So look at the sense in the sense whether it is clockwise or anti-clockwise. So it is causing the clockwise moment. So what it means is, as I said before, so moment of a couple about any point in the same plane is going to remain constant. So it is going to be the same. Is it clear to you? Next is resolution of force. So let me consider a force R. Okay. So I am going to say theta be the angle that force makes with respect to some reference axis. Here the reference axis is the horizontal axis. So I need to resolve this. What is the meaning of resolution? So resolution is nothing but splitting of the forces. Okay. So this force can be split into any number of forces, 100,000 forces. Again, when you compose all those forces, finally you will end up getting this back with the same angle theta. So for our convenience, what we do is we are going to resolve any given force into two components, in the horizontal direction normally and in the vertical direction, just to solve the given problem. Is it clear to you? So let me consider this force that is making an angle theta with respect to the horizontal. If this is the point O, I am going to call this horizontal axis as X, this axis as Y. So I am going to draw this line to some scale. Okay. Say if R is say 100 kilonewton, I am going to write 10 kilonewton equal to 1 centimeter. So here this becomes 10 centimeter and whatever the angle given. So we need to find out, or we need to resolve this force horizontally and vertically. So for that what I do is I am going to complete this rectangle okay. Starting from the tail, I am going to move towards the head. So I am going to put an arrow like this. This is the horizontal component. Arrow like this. This is the vertical component. Okay. Similarly, it is the same thing for a rectangular beam. And for horizontal, same thing. So let me call the horizontal component as Rx and let me call the vertical component as Ry. So I consider this triangle, this is a right angle triangle. So in this triangle, from figure, so cos theta equal to adjacent side divided by hypotenuse. Therefore, Rx equal to R cos theta. So Rx is the horizontal component of this force and Ry is the vertical component of this force. So by knowing the magnitude of this and by knowing angle theta, we can find out what is the horizontal component here. R is known, theta is known. Similarly, sin theta equal to opposite side divided by the hypotenuse. What is this opposite side? Because this is a rectangle, so Ry is the opposite side. That is Ry divided by R. Therefore, Ry equal to R sin theta. This is the vertical component of the force R. So observe one thing here, if you are solving a problem having so many forces, every time when you resolve a force, so you cannot keep writing this triangle and writing cos theta equal to adjacent side by hypotenuse, sin theta equal to opposite side by hypotenuse. So it is going to be difficult, to repeat the same thing, it is time consuming. The simplest way you can remember is any component adjacent to the angle theta is always cos. So what is this component? Rx, and this Rx is adjacent to the angle theta. So that means R times cos theta. Similarly, any component away, this is away from angle theta, this is also away from angle theta. These two are the same thing. So any component away from the angle theta is always sin theta. That's why if you look here, vertical component is sin theta multiplied by the main force which we are trying to resolve. Is it clear to you? And as far as the directions are concerned, so here it is moving to the right, that is the horizontal component is pointing towards right and vertical component is pointing up. So let us follow some sign convention here. Sign conventions. So when it comes to the force, horizontal force acting from left to right as positive, then acting to the left, that is right to left, as negative. Similarly, any force acting upwards as positive and any force acting downwards as negative. Similarly, when it comes to the moment, any moment which is causing or which is rotating in the clockwise direction as positive and any moment causing counterclockwise rotation as negative. These are the sign conventions, and based on these sign conventions we are going to solve the given problems. Okay, if you want to change the sign convention, that is your choice, you can go ahead and change it. That means you can take this as negative, this becomes positive, this as negative, this becomes positive. So if you take this as negative, this becomes automatically positive. So that is purely your choice, but these are the sign conventions I am going to follow while solving the problems. So is it clear to you? So along the same line, if you look here, Rx I have written plus because Rx is acting towards right. According to our sign convention, it is positive. When you write the final answer, okay, strip off all those plus or minus signs and replace those signs with the direction. Okay, that should be your final answer. What I mean to say is, say for example, this component Rx is acting towards left. Okay, so towards left. So this becomes negative. So that is minus r cos theta. So when you are expressing the final answer, what you must do is take out that minus sign, replace that minus sign with the direction which is acting left. Okay, that is the final way of expressing the result. So is it clear to you? Now let us talk about composition of forces. So let me consider a body, and let this body be subjected to several forces all around. F5. See here, in composition of forces, it is quite opposite of the resolution of a force. So what is composition of forces? It is nothing but combining all the forces together and replacing those forces with only one force called the resultant, which will have the same effect as the main, all these forces combined. Okay. So let us take this example. So this body is subjected to several forces. So they are acting at different angles and in different directions. So I need to replace these forces with a single force such that that single force, I am repeating, will have the same effect as all of these forces combined. So to find out what is the resultant or that particular single force, the first thing we are going to do is we are going to resolve the given forces into two forces which are mutually perpendicular. So here I am going to resolve the force horizontally and vertically first. So let us work on this. If I take the force F1, the horizontal component of the force F1 is F1 cos theta, because this component is adjacent to the angle theta. So it is F1 cos theta, and the vertical component is F1 sin theta. Look at the arrows. So those arrows are acting towards the same point. So once I resolve this force into its components, so what I mean is I am replacing this force with these two forces. So I can forget this force. If I come here, the force F2, yes, it is already vertical and you don't have to resolve it horizontally because its horizontal component is 0. So component of any force in the direction perpendicular to itself is always 0. So this force is vertical, this does not have a horizontal component, so there is no question of resolving it. So coming to this, F3, this is inclined at an angle of theta 3 with respect to the horizontal. So let me resolve this horizontally. This is F3 cos theta 3 and the vertical component is F3 sin theta 3. So I can forget this. Similarly for this, so it is horizontal component, this is acting away from this point. So horizontal component is acting towards right and the magnitude is F cos theta 4. Similarly, vertical component is acting downwards F4 sin theta 4, sin because this component is away from the angle. Okay. And of course, when I come here, so I don't have to resolve this because this is already horizontal. So this does not have a component in the vertical direction. Now I am going to add all these forces algebraically in the x direction and in the y direction separately. Now algebraic sum of all the forces in the horizontal direction I am going to call that as Fx. If I take the force F1, it is F1 cos theta. So what is the sign for F1 cos theta? Look here, this is acting towards right, it is moving in the right direction. Okay, according to our sign convention, any force acting towards right is always positive. So by following this sign convention, so I am putting plus here. Next, coming to this F2, this does not have a horizontal component. Let me take this next. So the horizontal component here is F3 cos theta 3. But how is the force acting? It is acting towards left. So according to our sign convention, that should be negative. So that is minus F3 cos theta 3. Coming to this force F4, it is F3 sin theta, sorry, this is sin theta, also this is okay, F4 sin theta 4, and it is acting in the horizontal direction towards right, so it is plus sign. Next, coming to Fy, it is already the horizontal force which is acting towards right, so it is F phi. Sorry, there is a mistake, this should be cos theta 4. Okay, this is Fx. Fx is the algebraic sum of the components of all the forces in the horizontal direction. Okay, in a better way, that can be written as sigma Fx, because it will have more than one force. Similarly, sigma Fy is given by, again coming here, that is F1 sine theta. So what is the sign? It is acting downwards. So according to our sign convention, it is minus. Next, coming to F2, that is minus F2, because it is already vertical and it is acting downwards. Because it is acting downwards, it is minus. So F2 is the magnitude. Similarly here, when we come for F3 force, F3 sine theta 3 is the vertical component of F3, and the component is acting upwards. Upwards means, according to our sign convention, it is positive. So that is plus F3 sine theta 3, here minus F4 sine theta 4. Sine theta 4. So these two are the components of the resultant, final resultant we are going to get in the horizontal and the vertical directions. Is it clear? Now, when we add this number algebraically, this may be negative or positive. We don't know. The negative or positive depends on the values of F1, F3, F4, F5 and these angles. That is theta 1, theta 3 and theta 4 angles. So here let me assume sigma Fx as positive. So when I assume sigma Fx as positive, it will have some numerical value. So because positive means I have to show this in the positive direction of the force. So to certain scale, what we do, we are going to draw this and we are going to call this sigma Fx. Similarly, let us assume that this sigma Fy is again positive. When we assume that this as positive, then what happens? Sigma Fy will be acting upwards. That is sigma Fy. If you complete this rectangle and if you join the diagonal, this represents the resultant. And if I call this as theta, okay, if I call this as theta, so this gives the direction of the resultant with respect to the horizontal. Here I make a correction, theta 1, okay. Now let us find out what is the value of r. So that is the resultant. Therefore, the resultant r equal to square root of sigma Fx square plus sigma Fy square. We got the value of the resultant, but we don't know what is this angle theta. Unless we know, we cannot draw here, we cannot draw this, because we don't know at what angle we need to write the resultant. So to find out angle theta, what we do is, and tan theta equal to sigma Fy divided by sigma Fx, that is theta equal to tan inverse of sigma Fy divided by sigma Fx. So by knowing these two, so we can draw this resultant force. So now we know the magnitude of the resultant, we know the direction in which the resultant is acting. So that means these forces will cause the motion of this body in certain direction with certain magnitude of force. So you can take out all those forces. You can replace that with only one force R, and that force R should be acting at an angle of theta with respect to this horizontal on this body. This is called the composition of forces. That is combining all the forces and converting all the forces into a single force. So with this I am going to end this, but I need to add some more points to it. So here I said any component adjacent to the angle is always theta. Sometimes what happens, say for example I take this force, just say F6, okay. If I take F6 force, so let us say this is making an angle of theta 6 with respect to the vertical. So if I resolve this force vertically, so this is vertical component is F6 cos theta 6 and the horizontal component is F sin theta 6. Look here, vertical component cos theta, the reason is this component is adjacent to the angle theta 6. So that is why this is cos, and the horizontal component is away from the angle theta 6, that is why it is sin theta 6. Is it clear? So it is not always horizontal is cos, vertical is sin, no. So you need to look at the angle where it is acting, whether you are taking the angle with respect to the horizontal or whether you are taking the angle with respect to the vertical. Based on that you have to make a decision. I hope this is clear, and after this I am going to solve some problems. Thank you for this class.